If you remember back when we first talked about asymptotes and what they are, I kind of mentioned in passing that yes, sometimes it's possible for a function's graph to actually cross its asymptote. Right, so in this lecture, we're going to take a look at that whole idea in a little more detail. So first, let's start off with the easy one. The graph of a rational function cannot cross a vertical asymptote. Never. The vertical asymptotes of a rational function occur at the places where the function is undefined. So that just completely rules that out right from the beginning. Now, horizontal asymptotes, here we have, it could go either way, right? So how can we tell, right? How can we make that determination? Well, let's look at an example, right? I have a rational function here, and I want to figure out if its graph crosses its horizontal asymptote, and if it does, where. Okay, well, the first step in this is figuring out what the horizontal asymptote is. The degree of the numerator and the denominator are the same, right? They're both 2. So this graph does have a horizontal asymptote, and it occurs at the ratio of the leading coefficients. So in this case, they're both 1, right? It's that implicit 1 in front of the x squareds. So the horizontal asymptote occurs at y equals 1 over 1, which of course is just 1. Okay, so now we have all the information we need to answer our question. Phrasing this in terms of the function, what I'm asking is there an x value such that f of x is equal to 1, or y is equal to 1? So to answer that question, I'm just going to replace the f of x with a 1. Right? We get this equation, x squared plus 3x minus 4 over x squared minus 5x plus 2 equals 1. And now I need to solve this. And one of two things is going to happen. Either I'm going to get a solution, in which case the answer is yes, or it's going to turn out this equation does not have a solution, and then the answer is no. Okay, so how do we solve this? Well, the technically correct way is to set it equal to 0, find a common denominator, simplify it to a single rational expression factor, and all sorts of stuff. Look, I'm going to show you the quick and dirty way to do this, right? But you got to promise me you're not going to skip the one little check step I'm going to give you at the end, all right? Because it's important. If you do this the technically correct way, then you don't have to worry about it, but it's just a lot more work. So what I'm going to do here is I'm just going to eliminate the denominator. I'm going to multiply both sides of this thing by x squared minus 5x plus 2. That's going to cancel the denominator on the left-hand side, so the fraction is going to go away. And all we're left with is x squared plus 3x minus 4 equals x squared minus 5x plus 2. Whole lot simpler. Turns out it's even simpler than it might have looked at first, because those two x squareds, they're going to cancel each other. Now, that might not always happen, right? We just got lucky with this one. So I'm going to subtract x squared from both sides. I'm going to add 5x to both sides. And I'm going to add 4 to both sides. Right, so that's going to turn this into 5x equals 6. And if we divide both sides by 5, we get x equals 5 6. Now, here's the one check step I want you to promise me you're going to do. You got to take that 5 6 and make sure it doesn't make the denominator equal to 0. Right, so you got to substitute it back in there. It's 5 6 squared minus 5 times 5 6 plus 2, right? You got to get your calculator out, right? I don't need a fancy nice fraction. All I care is, does it equal 0 or doesn't it? If it equals 0, then the function is in fact undefined at that point, and the answer becomes no, it doesn't cross it. If it's not equal to 0, which is the case here, where you can drop it in there and check that if you like, then this is the answer to my question. First, yes, the graph does cross the horizontal asymptote. And second, it does it at x equals 5 6. Okay, so let's take a look at another one. And, spoiler alert, it's not going to cross at this point. All right, because I want you to see what that looks like. So we're going to take we'll follow the exact same set of steps. The y asymptote, the horizontal asymptote, still is happening at y equals 1. So I'm going to put 1 in for the f of x, right? We get x squared plus 3x plus 2 over x squared plus 3x minus 1 is equal to 1. And I'm going to do the same little cheat, right? I'm going to multiply both sides by x squared plus 3x minus 1. That's going to clear the fraction. And we get this thing, x squared plus 3x plus 2 equals x squared plus 3x minus 1. Hopefully you can see already, right? Yeah, we're going to have a problem here. I'm going to subtract x squared from both sides, so they're going to go away. And I'm going to subtract 3x from both sides. And those are going to both go away as well. And all we're going to be left with is 2 equals negative 1. Well, that is never true. Right? There's no value of x that's going to make that happen, which tells me that this equation has no solution, which tells me that the function is not going to cross that horizontal asymptote. Okay, so now we've got a bunch of tools in our toolbox. We know how to find the domain of a rational function. We know how to find the asymptotes. We know a little bit about what the asymptotes are going to kind of do with the graph, and we know how to answer this question about whether or not the function crosses its asymptote. Those are going to be the key tools that we need to come up with a pretty decent sketch of the graph of a rational function. So in the next several lectures, we're going to take a look at a few examples and see how we can bring all these tools together to make that happen.